you enjoy seeing that extension? Or- But it's too early to extend. Like, what is the issue away for the 14?
Make us suffer. Yeah.
Work hard, get ready. Okay. All right. Well, thanks everyone for joining in the room and via Zoom. It's a great pleasure to introduce Gabriel Nemirovsky, who is currently a PhD candidate within the Department of Philosophy at the University of York. I guess that will be the old York, not the New York, right?
Yes, Old York.
York, the real one. Okay.
Yeah, the original.
He initially served as researcher at the UKRA Trustworthy Autonomous Systems Resilience Node, working with a number of entities and researchers on problems related to what he's going to present today. And he's as a researcher in the resilience node, he helped create some ethical frameworks for autonomous systems, which in my opinion are very interesting and very timely. So today we'll have Gabriel presented this work on building a framework for trustworthy autonomous agents. And the floor is yours. It's great to have you here.
Right. Yeah, and thank you for having me, and I appreciate all of you giving your time, and yeah, I'm happy to be here. Okay, so I'll be speaking to specifically a lot of topics on a paper we've actually published that I co-authored with several other people as part of this kind of general project within the node, this resilience node that I'll mention in ahead, coming up now. And this is kind of just to give a preliminary framework to see how we can actually talk about, machines that align with our values and so on, which seems to be more and more urgent. So this whole project is within the UK Research and Innovation kind of center and trustworthy autonomous systems. That's what the TAS means. And the TAS hub itself was given £33 million, and it's a program that coordinates between the 6 other research nodes. I'm in the resilience node. Each node is kind of dedicated to specific problems and concerns about autonomous systems. So as you can see there, with like governance and regulation, security, functionality, responsibility, etc. And it's all kind of coordinated through this hub. So ideally, then it kind of all comes together and we have these more cohesive frameworks. And it includes government, industry, NGOs, lots of different actors, because the idea is to help create policy, not just for government, but for industry, to see how to move forward with a lot of these systems. And because these are kind of complex problems, we have a lot of different people, engineers, lawyers, sociologists, and even philosophers, which traditionally, a lot of these disciplines don't often work together, but I think now more than ever, it's urgent to have these kind of dialogues across disciplines because, I mean, the philosophers obviously can't ignore the issues that come up with these new technologies, but also I don't think engineers can ignore the ethical or cultural or sociological kind of concerns here, because these systems will be involved in hospitals, universities, other institutions that will affect how we all live our lives and our well-being. So that's a big element there. And these are just some partners in various industries. So in defense and security, autonomous vehicles, healthcare, financial services. And kind of broad mission is to develop socially beneficial autonomous systems and that are trustworthy, right? So that's where my node comes in with resilience. So it's not just about systems that work well according to our, social or cultural or ethical expectations, but that remain resilient in, unforeseen circumstances. So if something comes up, we don't get surprised by like some crazy, output. um, and well, this is just the paper we published, From Pluralistic Normative Principles to Autonomous Agent Rules. Kind of a mouthful there, but I'll explain a bit coming up here. So today's talk is mostly about how do we start from these high level abstract principles about right and wrong into kind of an operational, embodied actual autonomous system. And the difficulty is that, human value judgments are very complicated. They involve overlapping relationships, family, friends, institutions like universities or, companies, and it also, might depend on the context, time, place, the purpose that certain technology might serve, what's supposed to be the outcome. And this kind of non-linear, very complicated sort of relationships, and it's not always easy to explain why and how we value something. On top of that, we can have conflicts between two different decisions or two or more. And it might not be very straightforward because they might be incommensurable, right? Two things that you can't really compare with one another. And the question is, how can you even move forward? And another thing I want to say is we're not concerned about building moral machines if a thing's even possible. And by that we mean like a machine that itself, is making moral decisions. It's a moral actor, so to speak. So, I mean, there's a question. At least current machines, I don't think are capable of this, and whether or not they ever will be. There's also a question of whether they should be capable of that. But we kind of don't really go into that question. We talk more about value alignment. So how autonomous systems might align with our values, not and kind of work with them, but not necessarily saying that the machine itself is moral or a moral agent. And here, well, I'll discuss this further on, but we have this acronym SLEEC, SLEEC, because we also look at what's normatively relevant in decisions. So we kind of condensed it to there's like social norms, legal norms, ethical norms, empathetic and cultural norms. So all these are kind of broad, very broad norms we need to keep in mind and how an autonomous system might affect them and how they should meet our expectations in these different kind of domains. So, autonomous systems, especially algorithmic ones, we stay away a bit. I don't know if a lot of this is applicable for like artificial general intelligence or anything. We're more concerned with just specific, autonomous agents. So mostly we've looked at case studies with actual robots, like search and rescue drones, certain robots that might help in a hospital with triage or, so they're very specific, use cases. And I don't know if this would apply to something as broad as artificial general intelligence. So we do look more at algorithmic systems, and they do tend to be very strongly rules-based. So they can be very efficient and powerful, but they more or less function at a level of like an apprentice learner. And I'll discuss that a little further on. Why I say that. But there is this issue with, these sleek norms, even legal norms that often might be structured as, a very specific rule, depending on your moral or legal theory. That might not necessarily be the case. It's not these kind of discrete, well-formulated facts. And it's a little difficult to then, assess how these systems should move forward in these kind of complex contexts. And so we need I think one important thing to keep in mind is the context in which an autonomous agent is deployed should be narrow and very well defined according to its functionality, according to these rules. Because, the wider the context, the more complex the situation, the more kind of things to keep in mind, right? With the sleek, and things get complicated and might kind of be a little more difficult to articulate than just kind of saying a set of rules. So this goes on to my next point, where we have two interrelated senses of the word rationalization. So the first sense is kind of a positive sense of the word, in which we offer valid explanations to why we did a certain thing for our decisions. And we combine those with elements of a decision rule, and we justify that decision. We're able to explain the steps about why we did something. So if someone asked me to explain why I went to Safeway today, I can say, well, I wanted toast, but I was all out of bread, and kind of give this whole kind of step-by-step explanation that makes sense. But there's also a second sense of the word, which is derogatory, which is kind of ex post, trying to, like, you did something kind of impulsive, and then someone asks you, why did you do this? And you rationalize it after the fact, right? This is as you kind of invent reasons. And there you see a little Calvin and Hobbes comic kind of illustrating that point. So that's another thing to keep in mind. I think autonomous systems, their decisions should be explainable. And we shouldn't, rely on this derogatory sense of rationalization kind of ex post. And the difficulty is with human decision making, to emphasize this complexity, and to go back to this, why, autonomous systems, while they can be very powerful, in many ways surpass, human capabilities. At some level, they're always kind of this sort of apprentice stage learner. Because there are these kind of theories of human knowledge in which how we develop intuition. So I illustrate this with Picasso, for example, where if you want to become Picasso, or not literally, but a master painter, you kind of first have to learn basic facts about painting, kind of discrete facts, not necessarily all connected yet. Then you learn some standard rules, and you start kind of learning about the shapes and how they relate to each other. And you might be assigned to start copying, old other artists. But eventually, with enough experience, when you're really kind of at this master level, you start learning how to break the rules that you've learned, but not necessarily in these arbitrary ways. But though it's non-arbitrary, it's also difficult to explain. Maybe we can try to rationalize in that derogatory sense, but it's not very explanatory. It's difficult. But usually we consider humans moral agents. So they are morally responsible for the decisions they do, but we can't say the same for autonomous systems. So in a certain sense, we also wouldn't want autonomous systems to necessarily develop intuition, so to speak. Not that I think they could, but the it being kind of rules based is actually a good thing, because this means we can explain those rules back once a decision has been made. This just kind of further illustrates the previous point. The difference between kind of a human master or expert and what an autonomous system can or should be doing. And so here we want to keep in mind, going back to an autonomous system should make a decision. It should be explainable. As I mentioned before, we have this kind of the sleek framework, where we want to keep in mind these kind of basic large level principles in mind, but how do we put this into operational practice? So our general approach is we want to be kind of pluralist and non-prioritist. So what we mean by this is we come up with principles like non-maleficence, do no harm, right? Or privacy, respect for privacy, respect for human autonomy, etc. But we're, at least at this stage, we're not necessarily ranking the principles. We're not saying one's above another. So that, in that sense, we're non-prioritist. And plural, as in we consider multiple principles, not just kind of one, which I'll explain the issue later. And all of this is part of a dialogue with stakeholders. When we're designing these autonomous systems, we need to be this kind of pluralist, non-prioritist approach, because we need to be able to give and take feedback onto how an autonomous system or autonomous agent should work, according to what principles and how. So there's this top up and bottom down aspect. The top up is that we start at a very high level abstract principles, but then we kind of bottom up in that we're asking stakeholders what these principles should be, how might they imagine these principles working, etc. So we have this 5-stage process about how stakeholders might be going about thinking about these rules and how to develop them. And hopefully this will serve as kind of a basic framework for future, designers of these autonomous systems, to how they might think about developing the rules for these agents. So you would start by identifying some high-level rules like privacy, non-maleficence, etc. And then you would have to identify proxies, and within the system's capability, and kind of map them together. So by that could be a general principle, could be non-maleficence, right? Do no harm. But harm is quite an abstract idea. But let's say this autonomous agent is meant to be deployed in a hospital setting to help a patient get dressed, for example. So the do no harm principle, a proxy for harm might be, inducing anxiety or something, inducing anxiety is still kind of an abstract thing. A proxy would be something measurable like heart rate, right? So if you say, if the heart rate goes above X amount, this counts as kind of doing harm, or this counts as an issue. So that also has to map on the capability of the system. You need some kind of sensor or some kind of way to actually measure heart rate. So you start mapping these very broad principles to these proxies, and that also makes you think about what capabilities you should incorporate into the design of the autonomous system, and then how that all fits together. And then you identify sleek concerns. So you see, okay, in the context of medicine, a concern might be there might be kind of a social standard for privacy. There's certainly a lot of legal standards for privacy, especially in healthcare. Empathetic would be quite important, I imagine, in that context. So you start identifying what concerns, what issues could actually come up in this context. And then you kind of, the second to last stage is you see how these conflicts can be resolved when, have maybe two conflicting concerns, which should override the other and how and when. And you might redefine the rules. So you might keep on adding like do X unless Y. And then you keep on what we call defeaters, the unless, so you might have kind of a long string of defeaters like do X unless Y unless Z. And you do this kind of iterative process using these defeaters until you at least reach a stage. You could go on probably ad infinitum, but there's a certain point where, all reasonable concerns might be pretty much addressed, especially within, a certain narrow context that this agent might be being deployed. And at that point, you stop, kind of satisfied as long as all the stakeholders seem to agree. So here's an example of what I mean. If you have, we had a case study of a robot meant to assist dressing in healthcare contexts. So you can develop a rule that when the user tells a robot to open the curtains, the robot should open the curtains. So this is a respect for human autonomy, right? It should do what the human instructs them to do. But when you write that rule, and you may think, oh well, actually, unless the user is undressed, perhaps it would be inappropriate to open the curtains. So this is another concern, for privacy, which there could get tricky because there's also, social norms around this where perhaps the individual is not concerned with being seen undressed, but there's a general social expectation to not see other people undressed. So there's you have to weigh not just the user's wants and needs, but potentially other people within that context. So you might add this defeater that unless the user is undressed, then don't open the curtains. But then you might even come up with another defeater where perhaps a user starts becoming distressed if the system does not open the curtains. And that might compromise the do no harm principle or mental health, for example. So that might potentially be an overriding factor again. So this kind of gives a clue about how the iterative process might work and how you might add defeaters to initial rules and how each kind of rule corresponds to a certain norm, right? Human autonomy, explainability, privacy, etc. So how do you identify and resolve sleep conflicts? Here I have an issue. Well, you could do kind of a traditional cost-benefit analysis, which might be very typical in economics or business. It has roots in utilitarianism and the moral theory. And there you kind of, everything is compared to kind of a third thing. So if you have a problem making the decision between X and Y, a monetary cost-benefit analysis might be, well, one's more expensive than the other. So according to my cost-benefit analysis, I would just do the least costly one in terms of money. But you could also define the coinage so to speak, as something else. It can be human welfare, preference, satisfaction, etc. So it's kind of a quantitative, very quantitative sort of way of analysis. Um, the only thing here is that we want to take seriously the sleek aspect, right? We want to take seriously that there's more than one human value. It's not I mean, I realize that's one concern we have, or I have personally, that a lot of these systems are developed and designed and put out by governments or companies and that have budgets, right? Reasonably, but that might potentially so it's quite hard to get away from that kind of cost benefit analysis. But if possible, when we're designing these systems, I think it should be kept in mind that there might be values that are not commensurable, right? That you can't just compare them to a third thing and measure them that way. So it's basically a way to take the conflict seriously, right? The decision between X and Y is apples and oranges. You could always compare an apple and an orange by their cost or by how much water it takes to make one or the other. But if you want to take seriously kind of the qualitative difference, like how do you actually qualitatively compare an apple and an orange? This is a much harder question. So obviously when it comes to like social or especially ethical dilemmas, we should keep that in mind, that they might not always be commensurable. So that's why we have initially this non-prioritist approach. We don't want to rank the principles ahead of time. We want to take them all seriously. Obviously, there's always some caveats, and you can't really ignore legal norms, for example, unless you want a heavy penalty. So in that sense, it's probably likely that legal norms will outrank social or cultural norms for very obvious reasons. You don't want to be breaking the law. So let me continue. So the question is, how would you even, for example, here where we have two conflicting norms. We all value information and transparency. But in a contradictory way, we also value, privacy. And so how do we actually evaluate this? When someone requests data from, should you give that data? Should you not? And the problem there is you do a traditional cost-benefit analysis, for example, with monetary cost as a criterion. The problem there is even if there's a legal fine, for example, for giving the data away, you could just kind of incorporate the fine into your cost-benefit analysis. And the problem there is it might still come out that you get more money by breaking the law than by not, right? By following the law. So this kind of straightforward cost-benefit analysis has it's a lot of pitfalls in that sense as well, and it doesn't accurately reflect human value judgments and how these autonomous systems should respect our sincere concern for transparency and for privacy, and negotiate how that actually comes out. Well, here we also have a very straightforward problem of just, the trolley problem, I suppose, but put a bit differently. Where, we have, if a dog on the road and a very expensive car, and should you respect for life and kind of swerve out of the way, potentially, putting a dent in your car? So what should you be maximizing if it's just money or welfare? And here the problem again, as I was saying, a cost-benefit analysis, I think the biggest issue is that it's a value monist rather than value pluralist, meaning there's actually only in the end one value that matters, which is that, either preference satisfaction or welfare, however you might define that, or, money. So when you compare two things, it's always compared to, the actual value of this third thing, which is the one that actually matters. But we want to be value pluralists. Value monism would kind of do away with sleek, right? There would be no actual conflict. It would just kind of be quite easily resolvable. So, there's a question of how do you actually even, put a value on the dog's life? It can't really be mathematically quantified, or at least perhaps shouldn't be. So how do you compare these like apples and oranges, right? These two incommensurate values. So here, our approach is more going back to that idea of explanation. What we want with stakeholders and those designing these autonomous agents is that there'd be a dialogue, and you're giving these kind of principles, and you're developing these rules, as I showed earlier, with kind of these defeaters. But you're giving reasons, and you're giving reasons for these rules, and you're constantly weighing these reasons against each other, but it's still not necessarily kind of a quantitative weight. Balancing is kind of a metaphor here, but it's kind of finding this kind of what the philosopher John Rawls would call kind of reflective equilibrium. So basically, there's always this kind of constant dialogue, and you're never quite hitting the exact answer, perhaps, but through the dialogue, you're kind of negotiating this kind of equilibrium where decisions kind of make sense, and you can kind of, depending on the context, prefer one principle over another. But these are still kind of done by, a collection of reasons, which still might not be as straightforward as, for example, if you did put a quantitative value, a hard quantitative value in each reason, the problem would be, there are very good reasons, and then there might be kind of less good reasons. So let's say I only have one good reason to do option A, and 5 medium reasons to do option B. But let's say that that one good reason for option A is like a very, very strong reason. Just because it's one reason against 5 doesn't necessarily then mean you go with the 5, right? In this kind of linear, sort of straightforward resolving of the conflict. So I suppose there the question is whether these values can be rationally resolved to actually kind of put them into a system. And here it's just kind of reiterating the problem, right? Here we have two, if in the medical context, two good reasons. We generally want to respect autonomy. But let's say a user refuses to take their medicine, and the consequences of not taking their medicine can be severe in their particular case. This is why we also talk about why the context has to be so narrow with autonomous agents. Because it has to really keep in mind these contextual things. For example, the consequence of refusing to take a vitamin, the autonomous agent might prefer to respect autonomy of the patient because the harm it causes to not take the vitamin is quite minimal. But if it's a life-saving drug, and for whatever reason the patient might not accept the medicine, perhaps there's this overriding reason to prevent harm, especially in healthcare context. So there you might want to design the autonomous agent to call in a nurse or a doctor, because there's also a question. The agent itself should not be forcing medicine on a patient, but there you would probably include, okay, this I do want to respect autonomy, but I don't want to do harm in this specific context with this specific medicine. So there should be some kind of system to alert human intervention to intervene and perhaps still override the user's decision there, or the user's autonomy. So this is why the conflicts can be quite difficult to negotiate, and why it's all very kind of contextual. And when you talk to stakeholders, we suggested one way to kind of maybe start taking some of this data to see how to negotiate and build these rules and the feeders is you can start writing scenarios. For example, the medicine could be insulin, and the autonomous agent administers insulin, and stakeholders can kind of fill in these stars according to how they interpret severity, how they interpret the importance of the principle in the abstract in this particular context, etc. And that's kind of a way to capture stakeholder data there. And yeah. So if there's any questions with the presentation, feel free to yes, Rodolfo. You're muted.
Before you go to bed, thank you for the great talk.
Yeah, you're welcome. Yeah, thank you for having me.
So yeah, time for questions. Rodolfo had a question, or
oh, you're muted. Your microphone's not.
Sorry. I was just about to jump because the last slide presented the most dramatic case I can think we have been living through. I mean, with the pandemic, right? The pandemic. I mean, people who refuse to be vaccinated, and the harm to the rest. But anyway, I have a question for you to start my second question. Are you familiar with the rules of robotics of Asimov?
Yes, yeah.
Okay, then I can pose the question. I see many points in which those seem to relate to it. As you know, Asimov formulated these 3 rules of robotics that you read them and you say, oh, they are very tight, very well elaborated, I mean, very well thought through. And then he writes a few stories showing the possible contradictions. So, and the interesting point is that these days, I mean, with all the enthusiasm or the hype with artificial intelligence and the concerns about artificial intelligence, people have been uh, refloating those rules and discussing those rules in the context of artificial intelligence. So do you see any connection, or I am too far from what is in your thoughts?
Yeah, and there are connections. I mean, what we're trying to do is build a framework, kind of for the design stage of autonomous agents to help develop those tools. So, I mean, we do get some ideas from kind of the European Commission for Human Rights, and we cite for our kind of general framework about like, that's how we developed the acronym SLEEK about like what and how, well, not how necessarily, but what autonomous systems should respect. The framework we wrote tries to be general enough where every engineer or whoever can then get that framework and apply it to their particular case and talk with shareholders about their very particular issue. But that's one issue I have with kind of, I think the broader the scope of an autonomous agent, so the freer it is kind of in the world, the less narrow the context it has, the more danger you have in running into those kind of contradictions that Asimov wrote about. Which is why in our paper, we talk a lot about very context specific. The rules have to be context specific. And this is also why I don't think it's a bad thing. It might have sounded like I was criticizing certain autonomous systems for being at the apprentice level rather than this kind of human, the master level. But I actually see that as a good thing because that means these autonomous systems can be explainable. If something goes wrong, you could at least kind of read back its thinking, so to say, so to speak, and kind of see what the rules were, how they were explained, and kind of what went wrong. Meanwhile, if you have that kind of black box problem, it's much more difficult, I think, to do that. I mean, I guess that's not new, but and the problems also with humans, the way we learn is we start kind of intuitive. First, we learn the rules. Like a child doesn't just become, an Englishman or an American or something overnight. But they first learn. They're taught the rules of, how to say hello, when to say hello or thank you or please, or about tea time or certain. And then eventually, you become a master of that context, so to speak, and you sort of kind of you just embody the cultural practices of, you just kind of intuitively become, American, so to speak, or like your mannerisms, your customs, etc. And it's not necessarily this like very illogical reasoned explanation that you can give for that. And I don't want, ideally, an autonomous agent that would align with our values would have to be one that wouldn't work that way, that can be explanatory, that I think I'm deviating a bit from the topic.
Yeah.
But there is an interesting book, I forgot what the name was. It's like More Rules of Robotics. Wait, I'll look it up.
Okay, thank you. I mean, this is certainly a very important work and very challenging. indeed.
Yeah. But yeah. Any other questions?
I guess I was very intrigued by how you quantify all the possibilities that you could have, not only on the cases of the situation, like you were talking about the dog and the car, right? You have multiple possibilities there of what could happen. And also you have multiple possibilities of what the morals of the parties really are. And those depend on upbringing, culture, religion, principles, regulations, and many more things that I don't know. And I think the intention here is really nice, is to be able to inform the design of autonomous systems, right? In the long term, I would imagine you envision that this trustworthy autonomous system tool will be part of the, let's say, the procedure of designing an autonomous system. So the question is, back to my question is, how do you quantify all these factors? Is there a database? Is there some sort of already well understood set of propositions, if you will, that you need to keep track of and consider? But at the same time, I think that those need to be calibrated to the current scenario, not only of the parties involved, but also on the personal experiences, right?
Yeah. Yeah, it's difficult because, I mean, in our paper, we did cite, for example, the European Commission of Human Rights, and obviously then there's like the GDPR. So there's kind of, those are good starting points, I think, to start developing rules of how for these autonomous systems. But then when you do get into specific like cultural context, it can be more difficult. And it's also harder to know how to design the system. So I think this wasn't my research, but it was within my node, the resilience node. I think we had some sociologists studying specifically for autonomous vehicles on how to overpass a bicyclist, and how that problem of overpassing a bicyclist. And they were going around asking people that exclusively drove, people that exclusively biked, and then people that did both. And they asked them questions like, how much room do you give the cyclists when you're passing them? How far do you stay from them? If you're not able to pass, how far do you stay from the bike if you're stuck behind them? Does your behavior change if if the cyclist is an adult and they seem, to handle the bike well, or if they're a child, or so all these different questions about how they handle what seems like a simple task of overtaking a cyclist, but for an autonomous system might be much more difficult, because those are also things that we might have implicit in our own mind when we do it, when we're driving, but the vehicle kind of needs to be taught how to do this. And one thing is, it shouldn't be strictly, there is a legal standard, at least in the UK. It says, I forgot how far away you have to be from the cyclist to pass them safely, but there is a legal minimum. But what the research found, which was interesting, is actually the social expectation, the social norm, was actually stronger than the legal one. So people actually, if they had the room, they would actually give more space to cyclists than what was legally required. So then that also is an interesting question about an autonomous vehicle. Should it just respect the minimum, like the legal minimum? Should it respect the stronger social norm? Which I imagine also might change depending on what country you live in. Like in Argentina, I know people drive very close to one another, and the norms might be different there, but and that might have to be something to take into account. But yeah, that's kind of one illustration about maybe how the qualitative research could be done to then apply to build the rules for certain autonomous agents, and the difficulties there about which rule to follow, like the social norm or the legal. Well, the legal obviously, but if there's like a social or cultural norm that's stronger than the legal norm, which do you respect?
Um, you have a reluctance, or you denied using strict priorities, and I understand that. I understand the motivation. It will be possible to consider, rather than priorities, to have weights for the different things that you would like to pursue, and changing the weights will probably bring up different solutions. Could that help in framing,
Maybe.
making it more flexible in terms of addressing a problem that, I mean, saying I don't want to fix priorities, I understand the intent, but it seems to be very, very tough, right? I mean, uh, and what are the consequences of moving weights in terms
Yeah.
of the desired objectives?
Well, the non-priority, yeah, I don't know if I made it very clear. I did go by it quickly because a lot of this is also at the design phase. So this is not necessarily how the autonomous vehicle or agent, sorry, should develop rules, with its own rules, or how it should learn, but the design of the rules themselves at kind of that phase. And the non-prioritist thing is kind of maybe once you start building the dialogue with stakeholders, with on how to develop, what rules to design into the system. Um, when you kind of first sit down, when you're all there together, at the beginning there should be nothing kind of a ranked priority. It should kind of just be a discussion about what principles are relevant for this context and how. But maybe once you kind of start developing this dialogue and building these rules with the feeders, like do this because it causes no harm, unless this happens because of privacy or whatever. There you could perhaps start prioritizing some things over others. And I suppose that might have to do with maybe changing weights. For example, the medicine case.
Mhm.
If the autonomous system's supposed to just be administering, a vitamin, perhaps the rule is like, well, you could maybe rank the administration of vitamin very low. So, it's not that important if the patient refuses a vitamin. But if they refuse insulin, this might be much more dangerous. And then that might have a much more weight because of the context of, the health condition and the patient, and what healthcare is supposed to be in general, if it's in that context. So there you might start adding weights. And we've also noticed that it could also be time dependent. So there might be some medicines, for example, and you could also build this into the rule. We have people building like the programming language for this with the defeaters and everything. So one of the defeaters could also be kind of time dependent. So let's say you refused the medicine once, maybe there's very minimal consequences. But if you refuse the same dose, multiple times through the week, perhaps the additional missing doses could actually add up to something more serious. So you could also add that into the language of the how you're designing the rule, where you add more weight to it as time goes on, and it becomes more important to administer the medicine if if they've already missed, 3 doses rather than just 1, for example. Or
Mhm.
Any other questions for Gabriel? Well, it's great to hear that you're also coming up with some language and programs about this. It's very interesting. So thank you again for your time. Thanks everyone for coming to listen. And I will stay here, Gabriel, for a few more minutes. If you have some time, we can chat a little more about the discussion that we just had, and then we can call it a day. But anybody who wants to stay is welcome. Thank you.
okay.
Thank you, Eric, for setting it up. So I'm very curious. I don't know, do you have a few more minutes, Gabriel?
Yeah.
So I'm very curious about whether there is a toy example that, we work on robotics, we work on robotic manipulators, ground vehicles, aerial vehicles. We usually design algorithms, but we have some experimental setups. And I was wondering whether there is a particular case study, again, toy example that one can say, all right, well, we designed this system, we program these systems to do a particular autonomous mission, but we don't pay attention to what you were saying, right? How ethical, how appropriate the actions of these systems are. So how can we incorporate those, what I will call to some extent, design constraints for the system, right? Because we want to, in addition to, let's say, take a quad rotor from point A to point B, avoiding obstacles, then we want to also fulfill meet other constraints associated to this leak framework set of constraints, right?
Hmm.
So can we come up with some redesign procedure that now, okay, there's a baseline design for the engineering mission, if you will, really not necessarily compatible with all these aspects that you're bringing up, but then now how can we bring those aspects into the picture and come up with the right design or redesign? Does that sound reasonable?
Yeah. Well, I think in the paper we have that kind of the 5-step process. I forgot where let's see if I can share the screen again. Right. But we have that 5-step process where, because if you're thinking also of the context of the autonomous agent, at least the way we have it designed in our process is oh, sorry, wait, got distracted. Just trying to share this. There we go. Kind of this step 2 part where the, I don't know if you see the mouse or not going on.
Yeah.
Where there, I think that could help incorporate some things in the design. I mean, there's a problem that you could technically go ad infinitum because you can think of like very improbable scenarios happening, like how should the autonomous vehicle react if a comet like hits or something? But
Yeah.
obviously the scenarios we would think up are maybe the most normal cases with maybe some perhaps not that unusual case, but maybe some emergency cases to make sure that resilience aspect, right? Because you do have to try to incorporate some resilience into the machine or into the agent, where if something semi-unexpected happens, hopefully it still responds in an appropriate way. But so you would have to think of what are the relevant concerns of, I don't know, a self-driving car, and it could be anything as severe as potentially hitting someone. For example, the cyclist scenario, how to overtake a cyclist. It sounds like an easy problem, but the more you think about it, actually, the harder the issue actually it becomes. for the vehicle. But then you also think of I don't know, there's been cases of vehicles just stopping in the middle of traffic and just holding everyone up, or
Mhm.
things like this. And so you would, I suppose, think of these scenarios and develop, and you have these principles about, okay, the vehicle should do no harm, obviously, either to the driver or to others. But it should maybe also respect certain norms about traffic, when to stop, and how, and there you might want to do some qualitative research with how people, human drivers might act and what their thought process would be. Like, if you encounter this scenario, what reasons do you have for, reacting in such manner or in the other? And that's when you might want to start developing these rules, and you'll have to see that kind of idea of mapping back the proxies. So obviously, a autonomous vehicle might not think the way a human driver thinks, but there can be kind of proxies for. I can't think of anything too specific now, but um, whatever the proxy for do no harm might be for a vehicle. Obviously, not hitting someone's a very obvious one, but there might be, less
But
less.
Gabriel, correct me if I'm wrong, but I have the sense, I mean, what you're saying is very valuable. Uh, I think that if I understand correctly, what you are saying is that the model somehow for that requires to incorporate a projection in the future. It's not just a single act, do this or do that, but if I do A, what happens next, right?
Mhm.
That's another dimension that is wow, very complicated, right?
Yeah. Well, yeah, these
Am I
can get very
wrong?
tricky.
Pardon me? Am I wrong about that?
Uh,
The model
no.
is not
Uh,
it's not a matter of deciding between oranges and apple. Is it invests is well, you are talking about the dynamic system, basically.
mhm.
Right. You need to know what the consequence of these actions could be,
Exactly.
right?
Yeah.
And assess those versus some sort of a cost function, like model predictive control, that, right? You have a system that you want to control, you have some inputs, you have some measurements, and now you essentially, even though this is expensive computationally, but you propagate forward in time over a finite amount of time the possible motions or the possible evolution of your system or your observations for the all possible inputs. And then you assess all these options based on a cost function, and then you pick an input that will minimize your cost function. If you want to minimize something, you want to minimize the error or you want to minimize the risk, right?
Mhm.
And that's a dynamic, as Rodolfo mentioned, that's a dynamic selection, right? It's not a static one.
Yeah. I mean, there is some difficulty in that. I mean, the language is a little beyond my own scope, the one that we're writing, but um, the programming language. But I mean, there's some room for it. Like I said, with like, you can make time dependent rules, although that would still depend on some forecasting, in the sense that we could probably forecast, if a problem goes so much time without being addressed, it can get worse. So you write a rule to address it before that happens. But I mean, but that's, I think, the problem of how dynamic the system is. It might just be, we can try to mitigate that, but it might just be a problem with unavoidable. I don't know, because I mean, something always strange could happen out in the real world where you have an autonomous agent just kind of interacting with people, whether it's a autonomous vehicle, or just some things we've been looking at, like kind of search and rescue drones, or this robot that helps with emergency room kind of triage, to either bring the patient, kind of whether the patient's very urgent or not, and I think, I mean, things could always happen that are difficult to control, I think. I mean, we found with the medical care robot and the triage, doctors did not have a lot of confidence in it. And it wasn't that they didn't really trust the technology, but they didn't trust patients to properly, because it would still require patients to put on, you know, the thing to measure heart pressure, right, on their arm, and it would require patients to do certain things themselves for the robot, and they just didn't trust the actual patients to do these things properly. So it wasn't as much the technology. So one problem is just people can be unpredictable too. And I don't know how to actually address that kind of dynamism, if I'm saying that right. And that might be almost impossible, or not impossible, to predict. I mean, I do believe, ideally, this process of making rules with stakeholders and doing this kind of qualitative research and mapping the capability, like mapping, you know, principles to proxies, and then seeing if your system's actually capable of measuring that proxy, right? Like the heart rate thing, right? If you want to not do harm as a medical care robot, one proxy for harm is increased heart rate, and you know that means, oh, I'll need to have a sensor to actually measure that, or else I can't make a rule about it. I forgot where I was going this, but in my opinion, I do think there has to be like regular meetings with stakeholders, maybe once every so often. I don't know how long, but that might also be contextual. But there might have to be ongoing discussions with stakeholders to build new rules, or to maybe eliminate old irrelevant ones, but to have the autonomous agent itself be like perfectly responsive to these dynamic issues, I don't know. That may I also see it as difficult. And this is a kind of preliminary framework to address maybe the more broad problems and increase resilience, at least to a certain extent. And I do think you could probably change the weights of certain things, because in the stakeholder discussions, you can discuss how, if, you know, certain changes might imply, you know, a whole new context now where applying the medicine is much more urgent, and so now it has a greater weight. But I think that's still something foreseen by the stakeholders in the design phase. And but yeah, I don't know how to get around that problem exactly with.
But I think that what you're doing is the right thing to do, is to look at different case studies, different situations, and try to start building the framework based on examples. That's a great direction, I think. Do you have any of these published already, or are you working still on the publications?
Well, the whole project itself has tons of publications. The thing I talked about specifically, let's see here. There's a paper already published. I'll share the screen again. So this is a paper I co-authored with several other people that talks about.
Oh, I see. Nice.
It talks about. Yeah, sorry. Yeah.
Good. Great.
Yeah, and
Cut it down.
yeah. If you want, I could also send it to you via email, and I think you can just download the PDF for free
All
but
right.
if not, I can also send it to you as
Yeah,
well.
If you could send us the link, that'd be great.
Okay, yeah.
Thank you.
Anything else or?
No, I think this was very, very good. Thank you so much, and I hope that you enjoyed preparing. The presentation was excellent. Very, very, very well done. So congratulations.
Yeah, and thank you for inviting me and having me here, and I enjoyed it as well.
Very good. And good to see you, Rodolfo, again.
good to hear you. See you. I am seeing you.
Muy bien. ¿Todo bien?
Sorry, we are a little far away. Otherwise, I will try to jump in more frequently. But
Very- Anytime. Yeah. But with the rain, it's hard to come here.
yeah,
Great. Well, great to see you, and thanks again, Gabriel. We will be in touch.
Okay, yeah, thank you. And then I'll send you the link to the paper as well.
chao, Gabriel.
Okay.
Gracias.
Muchas gracias.
Ciao.